Oh. Thank you, Praveen sir, for that kind introduction. So, am I audible, sir?
Yeah.
Okay, and is the presentation visible?
Yeah, make it full
Yes,
screen,
make
bro.
it,
Yeah,
Yes.
make it
good.
full.
Okay. So as far as this part of the presentation is concerned, we'd like to start this presentation with the circular that's put out by MORT, which is the Ministry of Road Transport and Highway. As my respected colleagues have already time and again noted out some of the statutory bodies that makes the rules and regulations for the for Indian roadways. So in the same way, MORT is an apex body for the formulation and administration of rules, regulations, and laws related to the road transport and transport research in India. So they have put out this circular, and if we see this circular, the subject line for this circular is the use of new alternate materials and technology in construction of highways. And this circular is dated 14th of December 2020. So as far as the materials that have been listed in this circular, these are the different materials that have been put forth by MORTH, and as such, MORTH is encouraging the adoption of such alternate materials for the purpose of construction of the pavement. This is from the point of view of both economy as well as from the point of view of the sustainability. Therefore, keeping in view this circular that's put forth by MORTH, this part of the presentation would be divided into two parts, wherein in the first part we'd be discussing the asphalt mixes, which will comprise of recycled asphalt pavements, the plastic mixes, the stone matrix asphalt, and perpetual pavements. And the second part would take into account the stabilization and the preservation techniques. So these are some of the materials that are being covered in this presentation, which is put forth as a suggestion by Morth. So if we see firstly we'll try to discuss about the wrap material. So usage of wrap is gaining prominence in India. So as far as wrap is concerned, the existing pavement materials after maintenance and construction processes, they can be reclaimed. Once they can be reclaimed, they can be utilized for the purpose of construction after reprocessing. So wrap mixes can be utilized for the purpose of resurfacing, repaving, or reconstruction. As the utilization of wrap is concerned, as far as the scientific community is concerned, they state that there are two major reasons for the purpose of utilizing wrap in the asphalt pavements. They can be the environmental and economic. So from the point of view of environment, we can state that the aggregates, which are the natural resources, whatever aggregates are reclaimed from a particular pavement during the maintenance, simply dumping them into the environment, that may create a problem onto the environment. Hence, instead of simply dumping the environment, dumping the aggregates into the environment, what we can do is that we can utilize such aggregates for the purpose of construction of the pavements. So this is the environmental reasons why we are moving towards the wrap mixes. As far as the economic reasons are concerned, what wrap enables us to do is that it enables us to utilize the bitumen that's already existing in the wrap. Thereby, it leads to the reduction in the expensive virgin bitumen. Therefore, what we can do is the large quantities of wrap that is getting generated during the maintenance and the construction operations that can be utilized for the purpose of construction of the pavements. So as far as the utilization of wrap is concerned, there are two primary steps for the purpose of incorporating wrap into the mixes, which has been put forth in the code that is being provided by Indian Research Indian Road Congress, ISC 120/2015. They state that in order to incorporate wrap into the mixes, there are two primary steps that need to be performed. First is the design, and second is the technology. Once these two steps are taken care of, the third step would be the performance and forms the terminal step. If the design and the technology are followed in a proper manner, then the performance is going to be expected. So as far as the recycling technologies are concerned, we can divide them into two parts, which can be in place and in plant. And each of these particular technologies have in turn the two variants, which is hot and cold. In the hot process, the existing pavement is heated by radiation and then it is milled or scarified, whereas in the cold process, the pavement is reclaimed by cold milling. So these have been listed here. If you see hot in place recycling, cold in place recycling, hot in plant recycling, and cold in plant recycling. So as far as the wrap is concerned, reclamation forms a very important part. So reclamation can be performed either by milling or by pavement demolition or by fill depth reclamation. As far as milling is concerned, it is the controlled removal of an existing pavement to a desired depth using a specially designed equipment. As far as the pavement demolition is concerned, it is a demolition of existing pavement using a bulldozer or backhoe. Pavement demolition is different as compared to that of milling because in pavement demolition, we are concentrating on the small area of the pavement. Therefore, it is slow and it results in large chunks of pavement, which may be more challenging for us to process. And the third part is the full depth reclamation, in which the entire depth of the pavement is removed. There may be a major difference between the full depth reclamation and milling because in full depth reclamation, the entire depth of the pavement is being removed, whereas as far as milling is concerned, it enables us to remove a certain bituminous layer and other granular or bound layers, enabling us to make a distinction between them. And therefore, it may be easy for us to stockpile the materials if we are milling the layers of the pavement separately. Therefore, as far as India is concerned, currently we had prominence of full depth reclamation for recovering the wrap material, but now we are undergoing a paradigm shift wherein we are going from full depth reclamation to that of milling. This has advantages because it may enable us to stockpile the material in the proper form and therefore enables us a stringent control on the quality of the wrap mixes. Since we are moving towards the utilization of wrap mixes in India, therefore we are also making a transition from the continuous plants to that of batch mix plants. Usually the continuous plants did not have any provisions for the purpose of introduction of the wrap materials. Therefore, the new batch mix plants that are coming into the industry, they are having the provisions for the purpose of introduction of the wrap material. So as far as the utilization of wrap is concerned, IRC 120/2015, what it states is that the wrap proportion should be less than or equal to 30%, or it should be less than or equal to 50%, but with rejuvenators. The reason for limiting the quantity of wrap in the pavement may be because of apprehensions in the industry with regard to how much amount of actual blending of wrap binder takes place in the pavement. Second, it may be because of variability in wraps from different sources. And lastly, it may be because of unproven performance in the field. But as far as scientific community is concerned, there is a major consensus that wrap does lead to improvement in performance of a particular pavement. Therefore, National Highway Authority of India, as well as Morth circular that we had seen in the first slide, they recommend us to utilize the wrap for the purpose of construction of the pavement.
For the audience, I just would like to add here, wrap, it is not a new thing that is there in India. In fact, we have been seeing a lot of interest among contractors use of wrap. But the issue is many of the contractors or agency assumes that using wrap is same, is just simply putting 20-30% into the BC or DBM and then go ahead with that. You see, it requires a lot of things. And you have to have the stockpile management. You have to have the how to fractionalize the wrap or how to manage the wrap, and also the mix design is also very important for that, and selection of the binder, selection of the bitumen. And one of the most important thing is the plant. How do you inject your wrap? What percentage of the wrap you want? You cannot say simply like hot mix, we are going 60%, 70%, 80%. That's not possible. You require to have the modernized plant. In fact, the plant we have as of now maybe go 30-40%, depending upon what kind of rejuvenator you are using, what kind of additive you are using, and where are you putting into that actually. So I think wrap, we have seen it is picking up. Many of the contractors and many of the agencies, in fact, they are now quite encouraged to use the wrap. So that is the kind of a development, and we hope, I think, in the coming maybe 5 to 10 years, a lot of things are going to go in this particular direction. Yeah. Over to you, Bra.
Thank you, sir. So next important thing that's been seen in the industry is that we're utilizing the plastic bituminous mixes. So if we see as far as the scientific resources are concerned, they have said that about 9% of 1,20,000 tons per day of the municipal solid waste is the plastic waste. Therefore, it is important for us to utilize because the safe disposal of waste plastic is a serious environmental problem considering that it is non-biodegradable. It does not decay over time, and even when dumped in landfills, it finds its way in the environment through air and water erosion. So the best way of disposal of waste plastic is its recycling to the maximum extent, and many developed countries have utilized the waste plastic to manufacture some various diverse products, such as even the railway sleepers. So in India, what has been done is that we have utilized the waste, the plastic waste for the purpose of manufacturing of the plastic bituminous mixes. And therefore, we have come up with a code for this. Indian Road Congress has come up with a code, IRC SP 98-2019, and certain features of IRC SP 98-2019 from the point of view of the mixed design requirements have been noted here, such as stability, the flow, the VMA, and VFB requirements. So as far as India is concerned, we are majorly using it in the varying course, and this code of provision is for the dry process, wherein the waste plastic is added after shedding in hot aggregates. So as far as the current scenario is concerned, the waste plastic roads in India are exceeding about 1 lakh kilometers or 0.1 million kilometers. And as far as the performance of these plastic roads have been seen, they have found to be better as compared to that of conventional in terms of their resistance to deformation, their resistance to water-induced damages, their resistance to their improvement in durability and fatigue life, improved stability and strength, and so on and so forth. And it's also sustainable, which is an added advantage. However, as far as the challenges for this plastic bituminous mix is concerned, the various challenges can be with regard to its storage stability, its unusually high mixing and compaction temperatures, and the provision of adequate reaction time, and also the cost. So as far as IRC SP 98-2019 is concerned, this may be interesting to note that it distinguishes the various types of plastics that can be utilized for the purpose of mixes as thermoplastics and the thermosetting plastics. As far as thermoplastics is concerned, IRC SP 98 specifically states that it is a thermoplastics that should be utilized for the purpose of manufacture of mixes because it softens on heating and again softens on reheating, whereas thermosetting plastic, once sets, it does not soften on heating. So this picture that you see here, this is the shredded waste plastic on which IIT Bombay has worked. We have worked on this in a lab for the purpose of a consultancy project. Dharan sir, you would like to add something?
Buran, I think just for the information here, yes, since we are talking about the new technology, so I just would like to add here, there are multiple challenges involved in using the waste plastic. We are saying waste plastic, but we wanted to make it pure plastic when we are trying to add into the mix. You need to collect the plastic, segregate it first of all in different kind of types, and then wash it, then shred it. Then how do you inject into the plant? It's very critical. I have seen some of the people are using the batch, this drum mix plant on the belt, just like with the hand they are putting it up and assuming that it is going. Right. And what kind of plant do you have, whether it is a parallel drum mix plant or whether it is a counterflow drum mix plant? It's very important that we understand how to use the technology, because otherwise it will backfire. And I myself consider there are certain challenges. I think we have to come across those kind of challenges. In fact, industry also, though there is a mandate to use it, but I have not seen a lot of like interest and like the positivity among the industry people that okay, let's go ahead and then use the plastic. So we need to be careful actually. Yeah.
So what about the melting point for the plastics? So that will
I think that is another very important point because you cannot use all kind of plastic into the plant. We have seen the balls of the plastic also into the mix. They does not melt at all. I mean, your mixing temperature is 160, 170. Some of the plastic, you can see the balls into the mix, and they are going to lie like that actually. So they may definitely, completely damage your payment that you are looking into.
Right. Thank you. Thank you, sir. So next emerging technology as far as India is concerned is the adoption of the stone matrix asphalt. So as my colleague Vamsi has already pointed out the various requirements for gradations and the mix design for stone matrix asphalt. So we'll be knowing that stone matrix asphalt is a gap graded mix. It is highly rut resistant. It is tough, it is stable, it is skid resistant, it has a high proportion of coarse aggregates, thereby providing high stone and stone contact. So as far as the manufacturing of the stone matrix asphalt is concerned, it can be either manufactured in the batch mix plant or it can be manufactured in the drum mix plant. So as far as the Indian scenario is concerned, it has been majorly adopted in the national highways, the state highways, and the city roads. And as far as the information from the site is concerned, satisfactory field performance has been observed in the Indian scenario. And major challenges can be with regard to the usage of the rollers, since the roller operators are typically familiar with rolling bituminous concrete surfaces, and therefore they may find difficult to understand the meaning of first pass as vibratory. Therefore, a strict check on the operator has to be maintained. Also, the stringent quality may also be a concern as far as the stone matrix asphalt is concerned. Dharvi sir, you would like to add?
Yeah, here I just would like to add something, Buran. I think SMA is now picking up in India, and we have been learning that that kind of mixes that we are using, particularly like bearing courses, and we have to go, like some kind of different mix, and considering high temperature, heavy loadings, and SMA is one of the kind of mixes that can help us. However, I just would like to add here the SMA mixes, the way we have picked up. I think we are taking it little light. We are assuming that it is same as BC or like other kind of mixes. Though it is good that it has been used, but certain principles has to be put up. First of all, like the production, the mix design, production, and also the compaction, and then how it is going to go into the field. And also the fiber plays very critical role. What kind of fiber you are using, how you are adding the fibers, and what kind of plant you are using. So all these things are very, very critical in using SMA. It is good, but if we don't have the good paving practices, so technology cannot help us. So just for information of all international participants and Indian participants, participant, SMA we have been picking up now in India. So hopefully it is going to go very successful in coming years. Yeah.
Yes.
Thank you.
So another thing that's picking up in India is the perpetual payments and the long life payments. So perpetual payments as defined in IRC 37 2008, it is defined as a payment that is having a design life of 50 years or longer. And in Indian context, we are preferring to design the perpetual payments as if the design traffic is greater than 300 million standard axles. So as far as the perpetual payment is concerned, if the tensile strain that is caused at the bottom of the bituminous layer is less than 70 microstrains, and which is within the endurance limit of the material, and the vertical compressor strain at the top of subgrade, these are the two critical points as far as the design of the payments is concerned. So horizontal tensile strain at the bottom of bituminous layer has to be less than 70 microstrains, and the vertical compressor strain at the top of subgrade has to be less than 200 microstrain. So if these two criteria are satisfied, it would mean theoretically that the payment is not going to fail. Therefore, this is the basis for the design of the perpetual payments. So the perpetual payment is designed in such a way that only the surface layer is sacrificial, which is to be scrapped and replaced with a new layer from time to time. Additionally, the National Highway Authority of India, which is again a statutory body and formulates controls the road network in India, it has considered perpetual payments to be an economical option due to the reduced life cycle cost, because it has a long life and therefore there may be less maintenance cost. Sir, you would like to add something?
Yeah, here this perpetual payment, we have recently a couple of projects which is running in India. Yes. And the top layer is SMA, and we have like DBM, like dense graded mix thickness of up to 250 mm, and then 50 mm layer of SMA. And the design we have been doing, and a lot of projects are coming up. We are hoping that I think this is the kind of recipe which is going to work for us, considering our heavy traffic and climatic condition. But yes, I think we have to also need to understand what are the design philosophy that we are using, and what kind of paving practices that we are using, and also what kind of make design performance test that we have to do, and how do we train the manpowers, actually those who can handle different kind of mixes. Maybe we are thinking like the next century mixes for us at least, which is going to give the long lasting payments, like in India. But yes, I think it is in the practice for all the international participants, and others also, like perpetual payments are there in the reality. I think this Mumbai Vadodara is expressway is coming up. Another projects are also coming up now on the perpetual payments.
Right. Okay. Thank you. So another thing which is important is the stabilization. So of the payment. So as far as IRC 37/2018 is concerned, it has pointed out two stabilization techniques. It can be the cement-treated sub-base or the cement-treated base, and they have been separate. It has a separate guideline as IRC 89. So as far as the cement-treated sub-base is concerned, these are the listed materials that can be utilized for the purpose of the stabilization of the sub-base. So generally we can say that it can comprise of the soil and aggregate or the mixture of the two, and it can be modified with cement, lime fly ash, and some chemical stabilizers, provided that the chemical stabilizers are complying with the specifications that have been laid forth in IRC 37. So the strength parameter for this cement-treated sub-base is the elastic modulus, which can be obtained from the unconfined compressive strength, and that has again been noted in IRC 37. As far as the cement-treated base is concerned, so for this we again have the mixture of aggregates. We can also use wrap material for this, as we'll see later, using the foamed bitumen or emulsion. And the different modifiers that can be used for this comprise of cement, lime fly ash, and again the chemical stabilizers. Usually we here are interested in finding the flexure strength or the modulus of rupture for the purpose of fatigue analysis. Sir, please add some information.
This is, I think, Burhan, this stabilization is another technique which is having a lot of interest in India as of now. Right. In fact, if you go further down, maybe the subgrade stabilization, right, which is, I think, has a lot of benefits in like your subgrade foundation is very strong. And then we have this aggregate layers we are also stabilizing. In fact, we are also doing full depth reclamation. There also we do cement treated base or sub base, like on top of that we have different kind of payment design that we can consider. And it is many projects have been done. It's not like now new in India. We have a lot of expertise available in market and like in the agencies and all. So this is going very well so far. But yes, still we need to give a lot of training to the people, a lot of understanding. Also, the field data has to be collected so that we understand that how do we refine our guidelines.
Right. Okay. Thank you. Again, in this stabilization, again, if we see IRC 37 also provides us with provision of the base layer when we are using an emulsion or the foam bitumen with the wrap aggregates. This is again a very interesting prospect because wrap adds to the sustainability, and the adoption of wrap in India is gaining prominence. So these are some of the specifications by IRC 37, such as the thickness has to be greater than 100 mm of this layer, and VG30 binder, the viscosity grade binder, because in India we are following the viscosity grading. So VG30 binder is recommended, and residual modulus, although being within a certain range, it has to be 800 MPa, and these are the requirements for the IDT strength. So here we have provided a schematic representation for the purpose of foaming. So as far as this foaming is concerned, so the foam bitumen is produced by injecting a small amount of water and compressed air in hot bitumen in an expansion chamber. It results in the expansion of binder into several orders of magnitude and consequently an increased contact area with aggregate particles. Therefore, it leads to the increase in the degree of covering over the particles. So this is again an interesting prospect. The foam bitumen emulsion is stabilization with wrap material. Dhanvi, sir, you would like to?
Yes, I think you're right, Burhan. Here, This is another technique that we are using for recycling, the cold in-place recycling, in fact, cold in-plant recycling also there. Yes. And we can use stabilization either using emulsion and then foam bitumen. And I have seen both these kind of techniques are in the practice as of now. And many projects have been done in India using like emulsion and foam, and then designing the different kind of composition on top of that. So these are the technologies which those are picking up now in India. In fact, recycling and stabilization and the foam and emulsion. And we hope, I think, in coming years, these are the future, because you save a lot of material and also a lot of, like the performance also comes up good actually. Yeah.
So can we use only virgin aggregates instead of the wrap material?
Some people tried that actually. You can they try to stabilize like some kind of aggregate gradation using emulsion and foam possible. The foam plants are also there that you can set up into the plant, but the more benefits are when you are going to use the wrap, because that's how you are going to save a lot of money into that actually. Yeah.
Right. Okay. Yeah. Thank you. Yeah, so next part, what is again we are seeing a rise in the usage of the geogrids. So geogrid is a geosynthetic, and as far as the geosynthetic is concerned, it is a product manufactured from the polymeric material, which is used with soil, rock, or other geotechnical related material, and is an integral part of a road project. Therefore, geogrids are the polymers that are formed in a very open grid-like configuration. The main aim of utilizing these geogrids is for the purpose of reinforcing, and because it provides a reinforcing action and also the stabilization, and therefore what it does is that it adds to the performance. So because of the stabilization using the geogrids, what happens is that it leads to decrease in the layer thickness, which in turn leads to the cost effectiveness. So as far as the constituent materials for the geogrids is concerned, it may comprise of polypropylene, high density polyethylene, and polyester. And IRC SP 59/2019 has specified the guidelines for the adoption of the geogrids. So it is very interesting to know that since the reinforcing is a very important point or part of that geogrid, therefore the specifications are majorly focusing on the tensile strength at the various strain levels for the purpose of the geogrids. And it's seen that geogrids is also gaining prominence in India. Sir, can you add some information?
I think this geogrid and geotextile and glass grids, surprisingly, we are seeing a lot of demand into the market now. Right. Maybe people have understood that. I think there is some benefits of this kind of technique, and which is certainly is actually. I mean, if you can use them appropriately, how do you design your pavement? Can you reduce the thickness? Can you like prevent the reflective cracks from the existing pavement? Sometimes there is a lot of cracks are there. Glass grid is being used. And many projects are on actually on the use of the geosynthetics as of now in India, and we hope, I think this is another technology which is going to pick up in coming years.
Right. Yeah. So again, yeah, NHAI has taken up major studies for the usage of geogrid to reduce the width of the pavements. So NHAI is also kind of encouraging for the purpose of adoption of geogrids. So finally, we also microsurfacing, which is one of the corrective measures that can be undertaken for the purpose of maintaining a particular pavement. As far as microsurfacing is concerned, it is a cold mix technique, and it uses the modified bitumen based on emulsion. It comprises of small size aggregates with the cement filler, and it is laid as a thin surface coat. So finally, what happens is this microsurfacing is utilized for the purpose of correcting the minor undulations and any skid minor undulations on the pavement, and it also provides a skid resistant properties to the pavement. So as far as IRC SP 81 is concerned, these are some of the major points that we have taken from IRC SP 81 as far as microsurfacing is concerned, such as we are using type 2 and type 3 microsurfacing, which comprises of 4 to 6 mm thick and 6 to 8 mm thick. Additionally, we also have some specifications for the aggregates, the emulsions, and mixed design. They are very detailed in IRC SP 81, although only some of these properties have been projected here. So ISC SP81 has been very specific in pointing out that microsurfacing should be adopted as a corrective maintenance only in such payments which are structurally sound. Their integrity should be there, and after that microsurfacing can be adopted. Dharamveer sir, over to you.
Yeah, Burhan, I thank you very much. I think you see, we have been doing a lot of construction now in India.
Right. Right.
And maybe the point would come. In fact, we already have certain saturation that we have already constructed the networks. And the biggest challenge is how do we preserve that? How do we keep good payment in a good condition by using the good technology at good time? And the microsurfacing, and also there are many other techniques also. There is a cap seal, microsurfacing, surface dressing is also there. Slurry and seal. You can use slurry seal is also there. Just these are the techniques we have been using in India. In fact, microsurfacing, many projects have been done. I just would like to raise a couple of points here. The quality of the microsurfacing is very, very important. Who is doing the microsurfacing, what kind of emulsion they are using, what kind of mix design has been done, and more important thing is where are you putting it. So I think it's not like a recipe which is going to save life of the payment, but you have to be very, very careful that how do we evaluate the microsurfacing candidate. So but we have seen some good projects and also some bad projects also in India on the microsurfacing.
Right. So finally, these are some notable mentions as far as aggregate materials is concerned, and bituminous binder and bituminous mixes are concerned. As far as aggregate materials are concerned, we are also seeing industry moving towards the use of synthetic aggregates, manufactured aggregates using captured CO2, sulfur extended bitumen as far as binders are concerned, bio-derived bituminous asphalt binders, and highly modified asphalt binders, which also go under the acronym HEMA. And as far as bituminous mixes are concerned, we are using warm asphalt mixes and porous asphalt mixes as well. So this is captured from an article in NBM and CW regarding the current practices as far as industry is concerned. Sir, you would like to add some? Yeah.
This is the last slide, Burhan, you have?
Yes, right. Yes.
Yeah, I think it's like it is very clear that we are moving in a direction of sustainability in terms of the recycling and cold recycling, hot recycling, preservation is also coming up. Perpetual payment we are thinking about, and also the alternate and marginal material, which is very, very important in coming years or so. We may need to have some alternate materials also. So a lot of work is going on the utilization of the slag also as of currently in India. So hopefully, I think this warm mix additives. And this is another area which, if you wanted to increase the use of the wrap, so WMA has to come up. Some work has been done on highly polymer modified binders, and other things are also in the practice as of now in India. Yeah.
Okay. Thank you, sir. Over to you, Praveen, sir.
Yes. Thank you so much, Burhan, for such a nice presentation. You have covered various aspects such as status of wrap utilization, then warm mix additives, then their uses in field like waste materials like plastic waste, geotextile, and with the relevant codal practice in India from different perspectives. It was really very informative. And also thanks to Professor Singh for providing further insight on wrap utilization, plastic waste utilization, road construction using the cement technology, perpetual payments, stabilization, geotextile, geogrids, and all. So with this, we have reached to the Q&A session. So in fact, we have got many questions from the audience, and this really shows that the audience was very much active in different sessions. We have got really very interesting questions. So we will try to address queries to the maximum possible extent. And for that, what we will do, first we will take up the questions based on first 3 sessions, and then we will come up with the queries based on last 2 sessions. Is it okay? So am I audible to everyone?
Yes, sir.
Yes. So so we'll now come up with the questions.
Parveen, just for the introduction of like audience, I would like to introduce you.
Yes.
And Dr. Parveen Kumar, he is the moderator of this whole presentation, and you have seen how effectively he has kept the timings actually of all the presentations. And now question answer session is also being moderated by Dr. Praveen Kumar. Dr. Praveen, he completed his PhD from IIT Bombay. In fact, he was one of my favorite students here. And this year, in the beginning, he joined as a postdoctoral research in Department of Civil Engineering at Hong Kong Polytechnical University. So currently, he is there, and he is working on various different research areas. And he has done on carbon nanotubes, like nanomaterials, and a lot of different activities he has done while he was here. So now I just hand over this session to Dr. Praveen, and he is going to take question answer. Now all the speakers, they can answer the questions. We will try maybe in half an hour or so, the question answer session, how much we can answer. So we'll try best. If not, then we'll try to maybe send you an email reply or something like that. And Dr. Sarif, you may also come in wherever some information is required to be add on. Actually, I just would like to request you on that.
Sure, I will.
Yeah.
Thank you.
Thank you, sir. Thank you for such a nice introduction about me. So we will come to the question part now.
Praveen, I would request all the speakers can come online so that people can see them and they can answer. Yeah.
So Arpita, Ms. Arpita, Burhan, and Vamsi, can you just switch on your video? Yeah. Still, Arpita and Burhan, I cannot see. Yeah. Now it's fine. So what we will do, we will try to cover up the questions from the first 3 parts, and then we will go for the last 2 parts. So there are some very basic questions which has come up. For example, somebody has asked, like, in India, asphalt and bitumen are different terms. So somebody is asking about whether asphalt is different and bitumen is different. So in my opinion, like, both are same. I mean, sometimes people use asphalt and sometimes people use bitumen, and depending on, in fact, from the different part of the world, somewhere they use asphalt and somewhere they use bitumen. So I would say that it's like an interchangeable terminology, which is based on their frequent use. They use it either asphalt or bitumen. Second question, actually, it is somebody has asked, like, PMB 82 minus 100 minus 10 is preferred in airfield. PG 76 minus 10 is preferred for highways. Other PMBs, particularly PG 76 minus 22, PG 64 minus 10, where it is used. So can I would request Ms. Arpita to answer to this query.
I can take up this, Praveen.
Yes.
This you see, this PMB PG has come up recently in 2019, and the production started, like, late in 2019 or so. And so 82 minus 10 we have seen used in airfield, but 76 minus 10 is also being used. And other binders, though they are there in the like IS 15462. But the selection depends upon the temperature also. What kind of temperature do you have? I mean, whether there is a minus 22 temperature or minus 10 temperature, or so minus 10, majority of the area you are going to see minus 10 is more than sufficient for us. But if you go for the cold regions and so, then maybe the minus 22 may come up. So it depends upon the area where you are going to use it. But majority of the area, in fact, in India, you are going to see 76 and 82. They are like minus 10 more than sufficient to use actually.
Okay. Thank you, sir.
But yes, cost is going to go actually. Yeah.
I have a follow-up on this.
Professor. Yeah.
Did you hear about any problems during construction of these highly modified binders in the field?
So, Professor Sarif, I think this is very good question. In fact, there was a concern that if you use, like very highly kind of PG82 and so, and that binder might be very stiff binder. And we have seen there is a practice also using the warm mix additive sometimes into the highly, kind of polymer modified binders. But successfully, we have also seen some of the project in India. They have planned such a nice manner. They have also used it. But yes, there are challenges that we have to be very, very careful. Otherwise, the workability is a major issue. Like that will cool down, and then like you may not be able to kind of lay it down within the time frame. Yes. We are still learning from that, so hopefully let's see. But majority of the project on highways, I have seen 76 is quite popular.
Okay.
Yeah.
Okay. Okay. So some question has come up about the measuring complex modulus for this Crumb rubber modified binder. So like they are asking about like what is the plate gap which we need to keep it when we are measuring the complex modulus of CRMB in the dynamic stereometer. So essentially, like of course, like this particle size is very important, because that the particle effect should not come into picture when you are measuring the any rheological parameters, especially for the CRMB, because it has different particle size range. So if you see the literature, based on the size of Crumb rubber, for example, if somebody is using, let's say, 80 micron or maybe 100 micron. So for that purpose, even 1 mm DHR plate gap is good enough. You may not find any effect, this particle size effect on the DHR result. But of course, like for example, if somebody is using like 300 micron or maybe 400 micron, so in that case, you see, like you have 300 micron size and particle gap, plate gap is just 1 mm. So definitely that ratio, if you see 300 micron and 1000 micron, which is 1 mm, so it is very small. So those kind of things you have to take care while measuring the rheological parameter for Crumb rubber modified binder. So depending on that, sometimes you can go ahead with just 1 mm, and sometimes you can go ahead with the 2 mm, or in fact sometimes even more than that. So Professor Singh would like to add on further.
Yes, I think you're right. And then there is another dedicated device that we have in our lab, which is called GTR Kit that we have with the DSR. And that is exclusively used for Crumb rubber modified binder, because there are certain challenges in using DSR for the Crumb rubber when you have the larger size of the particles and not very uniformly distributed. So we have another, like the device that we have in our lab, which we can fit into the DSR, which is called GTR, ground tie rubber kit. That can be used very effectively for measuring the kind of rheological performance of the Crumb rubber modified binders.
Yes. Yeah. Thank you, sir.
Yeah.
And somebody asked about the aggregate size selection, like how to select aggregate size to achieve desired gradation. So I would like to bring Mr. Vamshi to answer to this question. So Mr. Vamshi, can you just address to this question, how to select aggregate size to achieve desired gradation?
So how to select aggregate size to achieve the desired gradation?
Yes.
So it is like all about the type of mix we are going to use, like based on the traffic and climate conditions. Like this is, I think, select aggregate size in the sense of nominal aggregate size, I hope. So like this is all about the type of layer we are using and where we are using and the traffic levels and climatic conditions, what type of performance we are expecting. So based on that, we need to select whether the fine gradation or like towards coarse gradation. So I think that's it. I think Professor, I request Professor Singh to add.
Yes, I think this is what it is, and also you need to be very, very careful in thickness to nominal maximum aggregate size ratio. It is very, very critical, because what kind of aggregate size you are using and what thickness of the layer you are providing, only that particular mat. like typically it has to range from 3 to 4. Your thickness has to go 3 to 4 times of your nominal maximum aggregate size. But we have seen that in the practice it has not been followed, and this has a very detrimental impact actually onto the overall performance. Your permeability of the pavement is going to go, your density is not going to achieve, your workability is going to be an issue. So we have to be very, very careful that how do we select the aggregate size. And also, if you keep your low thickness with respect to your NMS, then your density is not also going to come. So I think these are the selection parameters that we have to be very, very careful into the field.
Yeah. Thank you, sir. Yeah. So another question has come up regarding in the very beginning, like about the road classification system in India. So somebody asked like how this national highway, state highway, and district roads are different. And to add to that, they have further added like, is it only for hot mix asphalt roads, or it includes for the concrete roads also? So in my opinion, like this road classification has nothing to do with the whether it is concrete road or bituminous road.
Yeah,
it is for all, and also
right.
like the importance of the road, and then the kind of agency involved, and the kind of this load it is going to take up. So there are many factors actually which are important, and accordingly we that road being constructed by this central agency or state agency, or maybe with their combined effort. So maybe Bharat can further add on to this. Dr. Bharat, can you just add on?
Yes.
Yeah.
I agree with your views. Actually, I think this question was asked by Mr. Debela. And if you see this difference actually, so state highway, national highway, in India, for like kind of a design point of view, we give equal importance. So no such difference in design point of view. But yes, sometimes in national highway there may be higher traffic, and state highways mostly, as you said, it's like all about territory and all. It's like more confined to the states or some interstate connectivity. But national highway has major role, that kind of thing.
Yes. So another interesting question has come up on this overlap for VG30 and VG40 grade. So I think this question was asked by Mr. Deepak. So essentially, like of course, as you rightly mentioned, there is overlap. Let's say for the VG30, around like for VG40, if you take 20% plus and minus, and VG30 20% plus and minus, so some overlap will be there. But of course, like this overlap is there, but like along with the viscosity, you have to check for other properties also. So like you have to measure the softening point, you have to see the penetration. So like though that viscosity may have overlap, but once you measure other parameter like penetration and then and softening point and other parameters, so you may be easily able to differentiate between VG30 and VG40. So, Dr. Singh, would you like to add?
Yeah, you are right actually, Prabir. And also, if you see IRC 37 2018, that clearly says that if you are going to use VG40, the minimum viscosity has to be 3600. Though that is very, very clear instruction that has been given. But you rightly said, I think we should not only look into the viscosity and then classification is going to go, but other property also we need to look into actually how the other property look like. That also we need to pay the equal attention.
Yes. Thank you, sir. And another question has come up, like very simple question, like what is JNR? So JNR is nothing but like it is a non-recoverable creep compliance. Essentially, when we do this multiple stress creep recovery test on polymer modified binder, especially, or maybe Crumb rubber modified binder. So like you can measure this parameter from that test. So you apply load for 10 repeated cycle, and then how much non-recoverable strain is there and what stress level you have applied over there. So based on that, you can easily calculate this JNR. So essentially, it is one of the indicative parameters. Based on that, whether you can based on that, you can actually classify whether that particular binder can be used for what kind of traffic level, axle level, and this speed. So those kind of classifications see already show in some tables. Yeah. And another question has come up about the polymer compatibility with the binder. So, Mr. Arpita, if you can add on this, then that would be good.
Barbin, you can address this question. You have done a lot of work on the polymer modified binder.
Yes, I can.
So you can quickly address this actually. Yeah.
So, of course, like polymer compatibility is one of the issue. In fact, now also depending on the polymer interaction with the binder system and how you are processing it, so there are so many factors. So for example, if you are using SBS, if you see some literature, some of them say that it is compatible, some of them say that it does not properly homogenize and properly compatible with the binder system. So it all depends on the kind of process through which you have mixed it properly, whether that polymer had been digested or not, what kind of quantity of polymer you are adding. So for improving the compatibility also, there are different additives which we usually use. So for example, sulfur is one of the very popular additive which we use for improving the compatibility, because it improves the interaction between binder and their polymer. So also again in that case, like how much quantity you are adding about that sulfur, or and how much time you are giving for. Yes, sir.
Yeah, Praveen, I think you just in one word, I think if you summarize that, the source of the unmodified binder plays very critical role in the modification also. Sometimes the same polymer, will work over one particular kind of like unmodified binder, but it may not work for like other source of the same virgin binder actually. Yeah. So this plays critical role. So we need to also look into the chemistry of the what is the unmodified binder is there, and whether it is compatible with your SBS or not actually. Yeah. We have seen the challenges also actually. Yeah.
I like to comment here. I had a project before, and according to the polymer producer, they said that you can achieve certain BG grades at certain using certain techniques, and when you try these with different virgin binders, you cannot simulate the results. So it's really a factor or a function of the chemical composition and the properties of the virgin aggregate. So you have a homework to do. You have to actually work in the lab in order to satisfy and all the specs using a new polymer. It's not an easy process or a straightforward process. It's all the time there is a lot of homework to do in the lab.
Yeah, agree. Yeah, thank you, Professor. For adding. Yeah.
Yes. So next question is for Mr. Vamsi. So Mr. Ankit, he has asked, like, to determine OBC in Indian specification, is air void of 4% is the only criteria, or it is based on the arithmetic mean of 3 criteria like Marshall stability, unit weight, and air void? So Mr. Vamsi, can you just answer to this question?
So generally earlier, like we used to in the Marshall mixation method, we have like 3 to 5% in the range of air voids. So by taking the average of the thing, earlier we used to do, but after from past few years, we are taking the optimum bitumen content corresponding to the 4% air voids. So this is the thing we are following from past few years. I think now we can say arithmetic mean of like range of 3 to 5% also. It is coming 4% exactly. So this is the but we target 4% design air void content.
I just would like to add here this 4% air void. I think we need to also look into that because this is the practice. But is it really working out for us in the Indian conditions? And this is, I think, very interesting question. I think we need to look into that. What exactly is the design air void we have to take? Because for the airfield, because of durability, we go 3.5. But in fact, I have seen recently the Super 5 is also coming up, where they say the design air void is 5%, but field compaction is also 5% at the same time. So I think we need to look into that. So which is really, like optimum air void that is going to be suitable for the Indian condition. Though right now we are taking this is the mean and all, but I think we need to look into that. Yeah. Professor Sarif, in your country also 4% air void they take as a design air voids.
Yeah, we use 3 to 5% air voids for the weeding course layers, and 3 to 8% for the binder course layers.
Right.
I have a question here regarding Marshall quotient. You guys use like Marshall quotient even for the polymer modified binders if you use Marshall mix design?
Right. Yes. Yes.
And can you achieve these numbers with the heavily polymer modified binders?
This is very interesting question, Professor Sarif. In fact, in the data you will find it is achieved. In fact, many of the data we have seen it found like it is excellent. But in our lab we have seen for highly modified polymer modified binder it is difficult sometimes to achieve that. Because, and also I have seen this Asphalt Institute and also the guideline, they also relax some kind of requirement of the MQ. They say that MQ can be slightly more actually when you are using the polymer modified binder. So that is still I think that is a requirement, but we are now trying to focus more on the rating performance. Yeah, but yes, to answer your question, it's sometimes challenging to find out this MQ actually.
And regarding the rutting, I just noticed that your mechanistic empirical pavement design methods that you're using, it only focuses on the rutting on the top of the subgrade layer, even though you mentioned that in many of your pavements, you have a lot of rutting, confined in the asphalt layers. So what do? Do you have, a way to address this?
I think this is a very nice observation that you have picked up. Though if you go into the history of the models, these models were developed long back. In fact, that time the total, like the surface rating was taken up. And, like that time we were not having that kind of rich mixes like that we have right now. For example, like the DBM, BC or SMA and all. So whatever the rating was there on the top, that has been taken into the consideration for the development of the model. And it was assumed that the rating is, like the cumulative rating from all the layers actually. Yeah. But yes, now we are facing the challenges that majority of the rating is limited to the like the top layers actually. Yeah. But for that, I think some work is required, and also some performance indicator has to come up into the mix design. Otherwise, I think it's difficult to pick up actually through that equation.
Okay.
Yeah. Yes. So next question has come up for Dr. Rajan actually. So somebody is asking like the recent mold circular allows using international standards like ASTO codes as per different international codes. What is trying to say that recommended UCS value seems to be on the lower side for the soil cement basis. So what is the criteria of IRC of corresponding higher ranges of UCS? Maybe after Bharat, maybe processing can add on to this question. Yeah.
Yes.
First,
So I think that question was asked from Mr. Nagendra.
Yes.
And if you see this Indian kind of what values we are using for the UCS in cement stabilization, it's around like 4.5 to 7 MPa. And if you see this international, some literature like California Transportation Department and all, so there's it's not a kind of we should go ahead with the higher values of UCS. There's a kind of negative effects, and the major effect is the shrinkage cracks. So this California department and all, they use around typical 2 to 4 MPa in this CTB. And if what we fear actually, if your UCS will be higher, then there may chances shrinkage crack will develop with the time, and that definitely will not good for the pavement structure point of view. So maybe Professor Singh, if you can add.
Bharat, you are right actually, because in fact, but I have also seen the higher limit also in some of the literature. But I do feel I think we need to limit it. Though we are saying cement destabilize subbase and base, But other country, you are not going to see the definition of subbase and base. They have the stabilized layer, and the stabilized layer has this kind of ranges. They say, you know, like different kind of ranges are given, UCS and all. But yes, if you go for very high UCS values, then there are certain challenges that you have to handle. The reflective cracks may come up, the cracks may come up, and it may not behave as expected. So those kind of things we have to take into the consideration. Yeah.
Yeah. Thank you, sir. So next question is again for Dr. Rajan only. So which is the most effective crack relief layer over stabilized basis? So after Dr. Rajan, if Professor Singh also can add on to this, then that would be good.
Okay. So maybe I don't have any experimental data, maybe what kind of layer may be more effective. But definitely we have to provide the crack relief layer on top of the CTB. But in some practices, I have seen people are doing some, when we construct CTB, so after 48 to 72 hours, they put some vibratory roller for maybe 3 passage, 4 passes to develop some very micro cracks.
Recracking,
so,
yeah.
Yeah, so these vibrations help to like minimize future wide range, wider width cracks, shrinkage cracks in this. But this comparison, I don't have any data on that.
In that I would like to add, Bharat, there can be 3 approaches. And I will also request Professor Sarif if they are adding, like we are talking about this cement stabilized base. On top of that, you know, like what kind of layer are you putting bituminous mixes directly on top of that, or you have some other layer in between actually. So in India, we have the practice that if we have the cement stabilized base, we are going to put some layer which is going to prevent the cracks. So there can be 3 ways of that. One is we are using aggregate crack relief layer. Then we are using this stress absorbing membrane interlayer, which is, you know, like kind of a chip seal kind of thing, you can say, surface dressing kind of thing, which is the polymer modified binders. Other things can also, you can think about the glass grids, which is also I have seen into the practice. And in fact, I would like to add fourth also. Fourth also, I have seen there is no crack relief layer also. In fact, but you have to be careful. What is the thickness of the top layer on top of the stabilized layer? So all 4 things I have seen. In fact, in the I think Middle East somewhere, I think Qatar, they have cement stabilized base, but there is no crack relief layer, but they have a very thick pavement on top of that. In fact, in Europe also I have seen that kind of practices. But in India, we are using SAMI or aggregate relief layer. Some project I have also seen the glass grid layer also being used on top of the CTB. Professor Sarif, you would like to add something here?
Yeah. Yes, in addition to this, all these are workable and you know, good practicing techniques. And I would like to add to this, in Egypt, our practice is to limit the UCS value of the stabilized layers to, you know, the lower limit. So in this case, you won't have to go with the crack relief layers or, you know, separator crack arresting layers between the asphalt layer and the stabilized material. And also, we add some kind of enhancer to our cement. It's some kind of, you know, nanozeolite in order to reduce the possibilities of shrinkage cracks. So in order to go for like higher limits of the UCS, so in this case, we use, you know, the modified cement with the nanozeolite, which actually delays the or reduces the shrinkage cracks. And in this case, you can go for, you know, higher values for the UCS.
Okay. That's good information. Thank you, Professor Sarif. Yeah.
Thank you.
So next question has come up for Ms. Arpita. So somebody is asking like, which bitumen is the best for the regions where there is very high rainfall? So in my opinion, there is nothing as such specification for which binder you should use for the high rainfall region. But of course, like certain things you have to see, like whatever aggregate and whatever bitumen you are using, whether it is really compatible to each other or not. So that kind of things you need to really take care, and it's very critical. Yeah. Another thing is like we have been using a lot of anti-sticking agents, like hydrated lime, or there are also a lot of commercial liquid anti-sticking agent for improving the compatibility. that is another thing. And further, in those areas where there is high rainfall, definitely you have to take care of the drainage, because drainage is something which becomes very important for those areas where there is high rainfall. So I think if you take care of all these different aspects, so possibly based on the other factors like what is the load and other parameters, whatever binder you have selected, so with the compatibility and then requirement, and then with the drainage and anti-stripping if you have added, so I think that binder, that road will be fair enough to perform even in those high rainfall areas. So Professor Singh, if you'd like to add.
No, I think you are absolutely right. Actually, I think you correctly explained very nicely. So I agree with that. Praveen, how many more questions do we have? Because we have 10 more minutes to go, and we are going to wrap up after 10 minutes. So you need to plan your session accordingly and pick up some question quickly, and then to the point.
Yeah, so we will take another 2 questions. Yeah,
okay,
and then we'll see like further. Yeah, so somebody is asking like up to after how much years or so we can expect using super wave technologies in India. So Professor Singh, if you can add on to this, and also Professor Sharif further to this. So this is a little bit generic question.
Yeah, I think it all depends upon the industry when they want to pick up, and also the policy makers when they wanted to introduce. So academicians have no role in that. We can only disseminate the knowledge and educate people, disseminate the knowledge and show the benefits. And then it is all about the policy decisions and how agencies are going to pick up. So that's my, I think, views. Professor Sharif may also add into that.
Yeah, same here. We've been trying to convince, decision makers of adapting the super pave technology and super pave binder, at least super pave binder characterization, not even the mixed design using the super pave. But it takes time. People don't like the change always, and another thing is that you add one more material to worry about. Controlling more materials in the construction process is always difficult. You need to train the people. You need to get like new laboratories. Train the technicians, improve and enhance your mixed plants, look at your equipment. So it's not an easy process. It's takes a lot of time and effort, in order to change from one system to another, especially the super pave. Plus the cost of the polymer, and modifying your asphalt. So all these factors are hindering, the process of changing from what we have right now to, another system. But I think we are getting closer to convince the people, and maybe in the coming years we'll see, at least binder modified asphalts is being used in Egypt in the very near future.
Yeah. Thank you.
Thank you. So we will take the last question basically. So this is maybe Professor Singh can add on to this, and then further Professor Sharif also. So this is about the reliability. It's like question is, does 80% reliability means 80% chances of satisfactory performance? The definition of reliability in true sense means satisfactory performance probability. So in what sense we should look 80% and 90% reliability mentioned in IFC 37?
Just would like to give a brief background to Professor Sharif and others. We are doing the pavement design based on the reliability, like 80% reliability, 90% reliability, depending upon type of the pavement and the traffic. So for example, like expressway or maybe the high volume roads, we are going 90% reliability. But let me tell you one thing. I mean, reliability, mathematics, equations, numbers, they all are fine actually. But the most important thing is you have good material, you have good machineries, you have good people with you. But if you don't know how to pave it, if you don't know what kind of construction has to be done, what kind of quality control has to be done, and how machine has to be operated, I think number will not work out. So these numbers are only for just getting some another number out of that actually. So let's not go into the believing it is like kind of somebody is, like saying that 90% mean 90%, 100% confident or 90% confident. So let's also try to improve the, like the paving practices before we trust onto the numbers. So that's my, like personal opinion that actually.
Okay.
Yes, I totally agree with you here.
Yeah.
Reliability in our pavement design is, like the factor of safety that you guys studied in your undergrad courses.
Right.
But this is a factor of safety that is based on statistics, mean and standard deviation, because we have lots of variabilities, as Professor Singh noted, in the material properties. You have a 100-kilometer road, so definitely you're going to have different materials across your pavement. You have different subgrade properties. You have, uncertainty on your traffic estimation for your project. You have a new road, and then you estimate, the future traffic for 20 years ahead in the future. So because of the extensive, variabilities in all the inputs of your design, structure design, so you have to use some kind of factor of safety, which is the reliability approach. And, the reliability approach is a very smart way in order to take care of some of the uncertainties that you face when you are inputting, your inputs into the design layer. So this is a way to increase the thicknesses of the layer, but smartly, but I would also enforce what Professor Singh mentioned, that it's not only the thickness of the layers, it's also, the construction practices, the material qualities, everything counts here. So it's really important to take care of every single aspect of the road, design, material, construction, and also maintenance. So I would like to stress on that. It's a balance. If you miss something, so you're gonna lose. So it's really important to consider all factors that affect, pavement performance, and reliability is just a way to increase the pavement thicknesses based on, the inputs that you have.
Thank you. Yeah, Professor.
Thank you, sir. So with this, we wrap up the question answer session. So in fact, I know that there are a couple of questions which has not been addressed, but of course, considering the time constraint and all we have, we are stopping over here the question answer session. But I would definitely encourage whoever has put up the question and has not been addressed. So I just encourage them and tell them to send their queries to Professor Singh, and I'm sure he will be very much happy to respond to those queries and to clarify your questions. So can we show the email address on the screen, Professor Singh?
Yeah, I think you can project it, and I just so are you done, Praveen? Or yeah.
Yes, sir. I mean, just
okay.
Yeah. So he will be showing his email address. Whoever has not able to get the answer to their queries, so definitely they can answer to that.
Okay.
So finally, I thank Professor Singh, Professor Sharif, and of course the audience for listening to different sessions. And I hope that every audience must have got some takeaway messages from this webinar. And with this, I would like to hand over the floor to Professor Singh for closing remarks. Over to Professor Singh. Thank you.
Yeah, thank you, Praveen, for nicely moderating all the sessions and this webinar. Thank you very much and appreciate it. I would like to thank all the speakers, Dr. Bharat, Arpita, Vamsi, Burhan, and Dr. Praveen for moderating. And also, if you see in the background, we have the team which is working. We have a team, like those who are collecting the questions from the MS team. And we have a team which is focusing on, completely on the YouTube, that what kind of live streaming has to be done, how it has to be done. We have Ajay, we have Mohit, we have Rohit there, and we have Sashi. So all these people are working out very hard in the background, though you don't see them here, but they are the backbone. Without them, it's very difficult to manage this webinar. And we had, in fact, I just now checked it, we had almost 1,300 participants registered, Professor Sharif, 1,300. And in fact, at one point of time, I was seeing almost 330 or 50 in this room. and almost I think 200 plus were there on the YouTube. So on an average, it was 600 plus participants, those who were attending the session. And it seems like it is a quite good start. And I just would like to thank immensely to Professor Sarif, because this is the beginning of the collaboration that we have. And hopefully we are going to bring more interesting session in the future. So with that, I would like to just like give a floor to Professor Sarif to add on something into that.
Thank you, Professor Singh. I really would like to thank you and all your team, the speakers and the team in the background who facilitated and organized this very well informative webinar. I really liked it. I really gained from a lot of nice information here. It's very knowledgeable. Your colleagues and students actually had very nice presentations that I would like, to have them separately, presenting these, to my students sometime if they allow me and agree on that. And I really would like to thank you for. You have a wonderful team, and all of us, when we have a good team of students and colleagues, this helps us a lot to advance, the research work that we are doing. And I admire the research team that you have. And I also would like to thank you and thank all the participants. It's very well attended webinar. I didn't, think that we will have, this large number of people from India, from Egypt, and from other countries as well. We will look into, the participants and see the different countries that they came from, and we'll see that we have participants from different countries. And this will encourage us to keep doing, those very important webinars. And I guess we have a lot of interesting questions as well from the floor. This means that, what had been presented is really very interesting. So with that, I would like to thank you and thank your team and thank all the participants. And we will promise you that we will have, future webinars as well in the track of pavement materials and design and construction as well. And thank you.
Yeah, thank you, Professor Sarif, and also to all of your students, and also for circulating the information to your network. And we apologize if some of them could not get into the room. Maybe we can separately organize as you ask us. We will definitely do that. And all of our team members, this presentation was by them. I was just simply supporting them. I asked them to go ahead and then, do the presentation. And I think they have done a lot of hard work for last almost 1.5 months since then we started. So on the background, you see a lot of hard work, but they have delivered nicely. And in fact, you also supported us in between. And thank you very much with that. We'll again come up with the new kind of title of the, the kind of topics and all. So for the audience, I just would like to say that we will bring more such presentation in the future. This presentation webinar was 3 hours. We are trying to bring little shorter, maybe let's say 1 hour and then maybe 30 minutes or 40 minutes. And then have the question answer. More interaction has to happen actually. So in future, we'll try to bring that. So with that, I just would like to, anybody would like to say something? Speakers, Vamsi, Bharat, Dr. Parveen, Dr. Bharat, Arpita, just last few words. Yeah.
Yes. So thank you, Professor Sarif and Professor Singh for this kind of a joint venture. And it will help all of us to present the things, and definitely down the line we all will go in that line, academics. So that will give altogether different experience and exposure. And with that, I will also like to add our colleague Mr. Azhar, whose help in this YouTube live streaming and all is really very much helpful for all of us to solve this, because we were not expecting this kind of response from the
right.
Indian kind of our colleagues and all.
Bharat, some of the participants asking about the feedback link actually, though we did not think about the feedback process. Sorry, we thought maybe this is around 15 or 100 people, but I think we have been getting a lot of requests about the feedback, and in fact this is good because so that we can improve upon. And what we are going to do, we can circulate the feedback link later on because we have collected email and other information. We'll try to do that. If it is not possible in the future, we will keep things ready actually. I think your questions are giving us a lot of inputs. So, you know, like we'll improve upon actually from that. So next time when you see, we'll definitely give you the feedback link in the chat box itself.
Right.
Sure.
Yeah. Thank you. Yeah, Vamsi, anything you want to add, Arpita? Yeah, just
thanks to Professor Sharif and Professor Singh and also Professor Dr. Praveen for moderating the session and all. So it is a very good session. So and we'll I personally learned a lot many things in this webinar. So thanks a lot.
okay.
I am also very thankful to Professor Singh and Professor Sharif and all our teammates. It was a very great opportunity for me to be able to present in this webinar. Thank you so much. Yeah,
Professor Sharif, your webinar also is going to go like this. We are going to organize your webinar also like that. Yeah. And you are going to see a lot of interest in the Indian people actually about your presentation. I'm pretty sure on that. Yeah.
It is my pleasure. I'm ready.
Yeah.
Let's